Good morning, students. The last class we discussed about unit of the rate constant and we discussed the expression for the integrated rate equation for the zero order reaction. Today class we are going to study about integrated rate equation for a first order reaction. Okay, first order reaction. So see, before going to that, we will write the definition. Okay, it is a for first order reaction. It is a chemical reaction in which the reaction rate is directly proportional to the rate of reaction directly proportional to the concentration of reactant power is 1. Means for example you take N2O5 nitrogen pentoxide is decomposes to form nitrogen dioxide plus O2. In this, rate is directly proportional to Kn2O5. Here the power is 1. Means the order of this reaction is 1. Means the rate of reaction is directly proportional to the concentration of reactant power 1. Concentration of reactant power 1. Okay. It is a chemical reaction. Chemical reaction in which reaction rate directly proportional to concentration of reactant power is 1. Okay. Yeah, my dear students, you see, consider reactant gives product. If you write similarly according to rate according to law of mass action, rate is K equals R, giving the power 1 because that is discussing the first order. For that we are taking power 1. We know that rate is equals to minus dr by dt. If we substitute minus dr by dt equals K R1. Okay, on rearranging this reaction, we will get minus dr by r dash equals K dt. See, if we multiply by minus sign on both sides, dr by r dash equals minus K dt. If we integrate on both sides, integrating on both the sides, integration dr by r dash equals minus K integration dt. Okay, you see, now we are not talking about log. Why? Because it is based E, not base 10. Okay, the ln is equals to log base E x. Okay, log x is nothing but 1 by x. Correct? Now, if we apply this to above equations, we will get ln r dash equals minus kt by I. I, this is, you see, I is nothing but integral rate constant. I is nothing but integral, I is nothing but integrating constant, integrating constant. Okay, now we are going to discuss integrating rate constant to find the value of I. To find the value of I, we will take I. To find the value of I, we will take t is equals to 0, and r is equals to r naught. Then what happens to the overall term in the equation 1? Ln r becomes r naught equals minus k into 0, t is equal to 0 plus I, will get ln r naught equals I. Equation number 2. Equation number 2 in equation number 1. Equation number 2 in equation number 1. Then what happens? Ln r dash equals minus kt by I. In place of I, we can write ln r naught. Okay. Well, rearrange, you will get kt is equals to ln r naught minus ln r or r1. Okay, if you write r1, it's okay. If you not write, it does not matter. It is in the form like log m minus log n is equals to log m n. Correct? No, you see, it is in the form. We can write kt is equals to ln r naught by r. We can write now. Then we want to find the value of k. K is equals to 1 by t ln r naught by r. You see, the ln equals 2.303 log base 10. Okay, if you substitute this in the equations, then k is equals to value 1 by t ln 2.303 log r naught by r. You can write 2.303 by t log r naught by r. See, this is an expression for the first order. Can you understand this expression? Okay. You see, and come to talk, you see this equation. What I am writing in red pen, you see, this equation, we call that equation number 3. When come to equation number 3, it is in the form of straight line. That is y is equals to mx plus c. Like ln r1 is equals to minus kt plus ln r naught. What is the x-axis? X-axis is time. Correct? No. In y-axis, ln r. See, straight line forms because it's straight line slope. This is nothing but ln r naught. Overall slope gives minus k equals slope. Okay, this is the expression we got from the equation number 3. If you talk while getting the value, you see, while talking about this expression ln, where if you remove the t, then kt kt is equals to, for this equation I'm talking, if t goes to the left hand side, kt is equals to 2.303 log r naught by r. Okay, similarly it is y is equals to mx, it is also a straight line. Okay, similarly the formula, x axis is nothing but see mx. We'll come to talk, if you rearrange this equation, we'll get y axis is equals to log r naught by r. If you rearrange this equation, okay, if your log goes to the left hand side, it became log r naught equals kt by 20303. Okay, this is the expression we got. Come to time in the presence of x axis. Here the slope gives k into 2.303. You see, I am rearranging this equation. We will get log r naught by r equals kt by 2.303. Okay, do you understand these equations? Next, I am going to talk about half-life period. See, we are going to talk about half-life period, that is will represent t of, or you can tell that t 50%. Okay, this is the half-life period. What is this half-life period means? Time in which the concentration of reactant is reduced to the half of its initial. Means, see, means how can you tell? Okay, I will give one example. You see, I am stating that reactant gives product in t is equals to 0 seconds. The 10 grams becomes 5 grams. 10 grams becomes 5 grams. Means it becomes half of it. Means reactant becomes half of it. Half-life period is nothing but time in which the concentration of reactant is reduced. It is reduces to half of its initial value. Means half of, means how much the initial there, then it becomes half of. Okay, 10 if you take, it becomes 5. If you take 25, it became 12.5 grams. Okay, then become half of its concentration of the reactant. Will definition will write definition time. Okay, time in which the concentration of the reactant is reduced to half of its initial value. Example, you can write this only. Okay, for zero order, for first we take for a zero order reaction. First of all, what is zero order reaction? K is equals to r naught minus r by t. Correct? No, where t is equals to become t of, then what happens? The initial reactant means the concentration of reactant reduces the half of it. No, then r naught becomes r by 2. Okay, you understanding? Then we can tell that r equals r naught by 2. We will write r is equals to r naught by 2. Then if you substitute in the above equation, k is equals to r naught minus r naught by 2 by t of. Okay, what happens is both, see, it becomes R naught by 2T of. Okay, correct now? Write T of is equals to R naught by 2K. R naught by 2K. Then, if we talk the time taken, means half life period is taken in zero order is directly proportional to the concentration of reactant. Do you understand this equation? Yeah, we can write T of is directly proportional to the R naught, then reactant. Okay, when come to talk about the first order, similarly we will talk about first order. Means for a first order reaction, we have K is equals to 2.303 by T log R naught by R. Correct? No. Similarly, T becomes T of R becomes R naught by, because it is initial concentration. Okay, initially. Then K is equals to 2.303 by T of log R naught by 2. Correct? No? If we R naught cancel, overall what happens? The log 2 value is 0.301. Then 2.303 by T of log 2, because R naught is cancelled. Then we will write 230.3 by T of log 2 value is 0.301. Okay, if you multiply, we will get 0.693 by K. 0.693 by K. It is T of. Okay, T of in the period, T of is independent. You see, in the first order, this is the expression for the half-life period of the first order. We will write and T of is independent of R naught. Okay, do you understand this? Next we will go to solve some problems. Okay, we will go to solve some problems based on the first order, zero order and